Hi guys, I thought I'd do a little video while I'm waiting for some stuff to come in, do some bigger projects about bench power supplies and also about how you can use them to charge up lithium ion batteries. I thought that might be of some interest. So first of all, if you're looking for a bench power supply, then there are several options available. There are some really cheap ones that you might see on Banggood, AliExpress, and even on eBay and Amazon and so on. But if you want a decent bench power supply, there are a couple of features that you need to be looking for. In my bench here, I've actually got an old power supply here with analog meters on it. That thing I'm actually using in order to heat up my tea with a little heater. I don't tend to use it for anything else anymore because if you've got a decent bench power supply, one of the features that you need to be looking for is that it has an on and off button. So in other words, you can set the voltage, the current, and all those features. And once you've done that, then you want to be able to turn the voltage, the output on, without having to turn the thing on and off. This old supply over there, actually, as soon as you turn it on, it's got output. There is no other switch on there to actually control that. And of course, the controls on there are analog as well, and those little dials are not that accurate. So it's really hard to set up for accurate values. Now, these modern digital ones over here, they have settings there for the voltage, the maximum voltage that it should be producing, and the maximum current that it should be producing, which is this is the current. You can change it, and this is the voltage. It also has an over voltage protect and an over current protect, and we won't be using that right now. See, the both of them are off. But if you're, let's say you're charging something like a lead acid battery or something like that that has a linear voltage as you charge it, it goes up, and I think a 12 volt like a car battery, I think it goes to 14.2 volts if I remember correctly, 13.8 volts if it's fully charged without the charger on. So you could actually set that to a particular voltage, and as soon as it reaches that voltage, the power supply will turn off. And so it goes for the current as well, but we're not going to be using that here. This particular one also has 6 presets that you can actually program in order to, if you use common voltages with it, then you can actually set those. It has a menu in order to set these things up and so on, but I'm not going to go into that because that's not that important. So you're looking for a power supply that has a separate little on-off button for the output to be turned on and off without having to turn the whole device off. And also what you want is you need to be able to set constant voltage and constant current values. This says CV on there and CC, constant current, constant voltage. That's what you need in a decent bench power supply. This particular thing, I believe it is 30 volts at either 5 amps or 10 amps. I can't remember. It's at least 5 amps anyway. So when it comes to charging up lithium ion cells, there are some considerations. They are not like you don't use a linear voltage in order to you can't just set a voltage and hook them up and charge them. What happens is that they have a curve like this blue curve that you see over here, at first you have to apply, if they're totally discharged, like they might be at 2.9 or 2.5 volts even, at first you will have to enter the constant current mode. So the voltage will not be at the full voltage that you will end up with. But you got to protect the cell by setting constant current. Then once it gets to a certain value, now you're going to constant voltage mode, and the current that it will actually pass through the cell will drop exponentially over time. And this particular graph here, which I found somewhere on the after doing a Google search, it is suggesting a 3-hour charge cycle. Now, in order to make for that to be true, most cells have a rating on them, like this particular one here. Let me. This particular one here is actually 2183 milliamp hours. And in order to determine how much current to use, usually you halve that. So the maximum current for this cell should be something like 1200 milliamps to 1 to 1.2 amps of current would be appropriate to use. And as these cells get older, of course, they may not be able to use the full current anymore. In any case, so let's have a look what we've got on this thing. Now I've got an old cell connected to it over here, which is not actually not a very good one anymore. It has a internal resistance of like 221 milliohms, 0.2 ohms or something like that, which is much higher than what a good cell has. But in any case, it is not fully discharged. So when I turn this on, and as you can see, I set the constant voltage to 4.2 volts and the constant current to 1 amp. If I turn that on, you will see it is actually gone into the constant current mode already, because it's applying 4.2 volts, because it's over 4 volts already. It's not actually empty, and it is drawing 318, and it'll be going down 316 and so on as it gets full. Once you see that value to go, maybe, I don't know, about 30 milliamps or something like that, you would turn it off, because then you would consider it to be fully charged. However, to show what it would look like if it was in the constant current mode, we can actually reduce the current. Let me set it to, I don't know, 100 milliamps. Okay, set it to 100 milliamps. If I now turn on the power supply, see, you will notice now that the voltage is only applying 4.06 volts, and it is drawing 100 milliamps. So now it is in, as you can see on the screen here, it's now in constant current mode. Once that voltage goes up, then it'll switch over to constant voltage mode, and this would take a little while, but let's have a look what happens when I put it on 300 milliamps. So it's charging 300 milliamps, and it's 4.19 volts. As soon as it goes to 4.2 volts, that will change to constant voltage. See, there it went, constant voltage, 4.2 amps. So this is what would happen if you were actually charging it at 1 amp and you had a cell that was actually depleted, which means 3 volts or less. Anyway, I thought you might find that interesting. And then, as I said, you can time it for like 3 hours and then have a look at it. But once that goes down to 30 milliamps or something like that, I turn the power supply off, and then I assume that the cell is fully charged. Okay, so that's all I've got for today. I hope you found that a little interesting, and this is how you can charge lithium-ion cells on a bench power supply. And I'll think up something else. I'm waiting for some parts to come in from, as I said, from AliExpress to evaluate the soldering station and a few other things. So keep in touch, and I'll see you guys later. Bye bye.